Alright guys, let's continue with our polynomials here. This time we'll be doing some operations on them, adding, subtracting, and multiplying. And then in the next section we'll do division. First up though, I found this online. I know the last section we did a problem with volume, and I thought this was kind of cool. If you look at this here, so the volume, this is a cylindrical, with a circular base. So again, the volume of that's going to be the area of the base. Since it's a circle, is pi r squared. And then to make it volume would be times height. So with this picture, pi, in this case, they're telling us the radius equals z. So z squared, right, because it's radius squared. And then the height of this one, they're telling us if the height is a. And then if we take a look at pi here, the actual, oops, let me move this thing. The volume of this thing is, see it down here? We got there's pi times, this is the r squared part, and this is the height, so the volume of this thing equals pizza. Thought it was kind of cool, throw that in there. Not sure who made it, but give credit to whoever it was. It wasn't my creation, but thought it kind of fit in. So anyways, let's get into just a couple brief examples. Again, this is should be kind of a review. We did operations on functions where you add and subtract like terms, and you could multiply by kind of distributing and all that stuff. So this should be a pretty straightforward, quick section. Let's take a look. All right, so to add and subtract polynomials, okay, and again, polynomials are things that have x is raised to a positive whole number power, a string of terms. Like for example, this is a big third degree polynomial here, and then we would be adding it to a second degree polynomial here, also known as a quadratic function. So the idea with adding and subtracting to combine like terms, we just need to make sure they have the same exponent. Same variable, same exponent. So for this one, we generally want to do these in the standard form or standard order where you do the biggest exponent first. So there's a 3x to the third, and then there's nothing in the other term to combine that with. The 2x squared, and we're adding 4x squared. So 2x squared plus 4x squared is going to give us 6x squareds. Okay, then we have minus 5x combined with positive 2x. So negative 5, if we add 2, would bring that up to a negative 3x. And then finally, the constant term, we have a plus 7 with a minus 3. Those would combine to become a plus 4. And there's our answer. That's in standard form, and all the like terms are combined. All right, now with subtraction, you got to just be careful here because we are actually subtracting an entire quantity. So we're subtracting each of these terms. So at times we're subtracting negatives and subtracting positives. So my advice on these is just rewrite this thing without the parentheses. So you can kind of leave the first term alone, plus x plus 10. And then just remember we are subtracting each of those terms. So we're subtracting 5x squared. But then the next term, we're subtracting a negative. So I'm just going to write that as a plus 4x, right? Because we were subtracting and then there's a negative there. And then we were subtracting a regular old 6. Okay, and once you do that, you kind of rewrite this without parentheses. Now it's just a string of terms to combine. It's basically just like the addition problem now. So if we combine the like terms, again, let's get the biggest exponent. We have a 2x to the third, nothing to combine with it. With the x squared terms, there's a plus 8x squared and a minus 5x squared. So those will combine, right? Plus 8 with a minus 5 is going to become a plus 3x squareds. Okay, we can combine the positive x with plus 4x to become plus 5x. And then finally we can combine the positive 10 and the minus 6, add those together to become a plus 4. Okay, and this would be the final answer here. This is a new polynomial. It's the difference of the two, right? With subtraction, it's difference. And notice it's definitely a different answer than we got before. Actually, never mind. I thought I had used the same term. Sometimes I use the same. But yeah, each answer is a third degree polynomial in this case. And just watch out with the parentheses for subtraction problems. Okay, part of today, multiplication. And this one, again, we just want to basically distribute and make sure that we distribute every term that we need to. So what I would suggest, because sometimes these get, more and more terms, so just kind of start with the first term, and we're going to make sure to distribute it times each of these terms. Okay, and when we do that, when we multiply, we're going to be adding exponents. So the x times x squared is going to become x to the third. Okay, because remember, think of this as like x to the first, so we add that to the x squared to become x to the third. Then the second term, when we multiply the x times the 4x, it'll become a plus 4x squared. Okay, then the x times the minus 5 is going to be a minus 5x. And then we move on and we now distribute the 5 to each of these terms as well. Okay, so we're going to do the 5 times x squared, which would be plus 5x squareds. The positive 5 times the positive 4x would become a plus 20x. And the positive 5 times the negative 5 is a minus 25. And then we can simplify, treat it like an addition problem, combine the like terms. For a final answer of, we have x cubed. With the x squareds, there's 4 of them, and then 5 more, so plus 9x squareds. The x terms, there's minus 5x, and then plus 20, so those would combine to become a plus 15x. And then the minus 25 constant term all by itself there. So here's our final answer. Okay, we are in standard form. Okay, the exponents are decreasing from left to right, and everything that needed to be combined has been combined. All right, let's try this last one. Same kind of thing, just keep yourself organized, and let's make sure we distribute everything and then simplify. So we can start by distributing the 2x squared to each of these two terms. Okay, so the 2x squared times 2x would be 4x to the third. The 2x squared times the minus 3, we're just going to multiply the coefficients, to be a minus 6x squared. Then we'll go ahead and distribute the 3x to each of those as well. So the 3x times the 2x will become a plus 6x squared. The 3x times the minus 3 will be a minus 9x. And then finally we will distribute the minus 8, so minus 16x, and then a plus 24. And we'll just go through, combine all the like terms again and see what happens. So we have a 4x to the third, a minus 6x squared and a plus 6x squared are going to cancel each other out. The minus 9x minus 16 more would be a minus 25x. And the constant term is just a plus 24. Okay, so here we go. We kind of multiplied these out. We got ourselves a new polynomial. And just being careful with combining like terms and writing in standard form. That's all there is to these. So these could be as large as you want if you just follow the process and keep yourself organized. That's all we got to do. All right. Division coming up next time.